The JPA is another specification that we are interested in because we have to work with a relation database. It allows you to annotate your application with entities. So your entities are what gets your database. And it allows you to work with the relation database, provides an API that you can to perform the CRUD operation as well as to search to perform some queries. There are a few interesting JPI changes that have been introduced. The one is that if you are aware of Hibernate HBM to DDL, which allows you to create databases, now that has been replaced by standard properties, and there is a way to add indexes now on your classes. So when you have an entity, you can just mark it at the right index and define your indexes there. And there is a cool new API called entity graph, which allows you to specify which all objects you want to fetch from the database. Let's suppose you have a relationship between user and address, which is a one-to-many relationship. Normally it will be a lazy relationship. You can also mark it as eager. But let's suppose it's a lazy relationship. So in an entity graph, you can specify what you want to fetch from the database. So now all the lazy exceptions are gone. So you can specify the graph that you want to fetch from the database, and it will fetch that from your database. So let's just look at few of the things that I talked about here. So if I look at persistence.xml, so now these are the options that I'm talking about which are commented right now. So Java x.persistence.schema.database.generation. Earlier you used to use Hibernate HBM to DDL. Now this is gone. So this is a standard property. Now we have so Java x.persistence.schema generation. It can have multiple values like just like drop and create, just create. It doesn't have an update option. So if you are using Hibernate, you probably have seen an update option. It does not have an update option because that's quite risky. For database migration, it is better to use something like Flyway to do database migration. Then you can also specify the directory where you want to create your SQL file. So you can specify the directory and it will write those SQL scripts there. Just like with this Java x.persistence.schema generation script, create target and drop target. So it will create and drop scripts in this location. So for me, it will be in the SQL drop.SQL. So you can specify now these things. Again, they don't have currently value property for showing SQL, so I'm using Hibernate property here because the JPA implementation that I'm using is Hibernate. Apart from that, let me just show you one more thing. In my domain, I have one more thing. If I look at entities, profile, so you will see that now you can specify the indexes on your table. So you just have to use a table in your table annotation. In your table annotation, you can specify the indexes that you want now. So when the database scripts will be generated, those indexes will also be created. So now you can mention your indexes on the same on your entity classes, which you can also have. Apart from that, other Java E7 cool features, entity graph API, so I can just show you that as well. So if I just go to my profile repository, yeah. So you can see that I have a method called find profile with social connection. This is the method. So what I'm doing here is that my profile has a linkage with social connection, so one-to-many relationship. So here I'm defining my entity graph that I need to find my social connections when I find my profile. So to activate that, I have to provide a hint to the entity manager, and there are the value of the hint is fetch graph, which means I have to fetch all these values that I'm providing in my entity graph. So it will fetch all the data. Otherwise, it will be a lazy data. Either you have to open a transaction and get the data, or you just to find all the data here itself. So now entity graph provides you a clean way to define your entity graphs. You can also use these entity graphs in your annotation. So you can also have named entity graph, just like named query. So you can have that as well. I'm using the API way right now. So these are some of the cool features that Java E7 has provided in the JPA, and these are quite useful because they solve the real purpose that people need. One of the things that Java E7 does not provide that I mostly require in my application is that I want to store dates in one format like UTC, and there is no way right now. Anybody has worked with Java 8 date API? It's a clone of Joda type. It's a clone of Joda type, but it does not work with JPA 2.1 right now. So you can't take those advantages. So it's a very good API, but it can't work with JPA 2.1 right now because JPA 2.1 is Java 6 compatible. So it has time to reach Java 8. So this is the common problem that you will see in most of the applications, that you have to store data in UTC format. So that you can, and on the client side, you will take probably a user time zone to render it in the user time zone. The way that I have solved this problem, and many people have solved, is that there is a library called Jadira. if you are aware of that. It provides you a mapping that you can define on your entity. So like here I am on activity date, I am defining a mapping that please store my date using this data type. And what it will do is that it will always store my date in UTC format. So now there is one place in my entity model that I can define this annotation and all my dates will be stored in UTC format. It's a very mandatory thing if your application has to be used from multiple geographies. It's a must thing that you need to have. So another thing that I normally do in my entities is that I create a base class for my entity called base entity, which is very good practice that you can also follow. And I add fields for dates like updated and created. So whenever I'm updating my entity, I just change my date and creation when I'm creating an entity. Again, here also I'm using Jadira data type. So all my dates are in UTC. So I can be sure that once my data will be pulled up, it will be always be in UTC. And so on the client side, what I use is that I use a user cookie to find the user time zone. Based on the user time zone, I just render it to the user. So this is must if you have to work with multiple time zones. Another API that is very useful in Java EE world is bean validation. So bean validation allows you to put constraints in your Java entity or value object. So like if you want to make sure that the data that you're processing to the disk should also, let's suppose you're processing profile, and you have to make sure that username should always be there. So you can use a bean validation at the not null constraint to define your constraints. Okay, so that's an example of bean validation. So it's a basic status class which has couple of objects, a couple of fields. The first is message, the second is posted at, and third is URL. So if you look at the message and posted at, we have defined few annotations at the rate not null, at the rate size. So it defines that it should be not null and the size should be at the max should be 140 character, and posted at should be in the path. So you have defined that annotation here. At the rate unique URL is a custom bean validation. So I have written that so I can write my own bean validation here. And when I persist this data into this will be recorded, or when I am making a request, I will make sure that all this data is present in my request. So Java E7 has taken this a step ahead. So what they have done is that they have now allowed you to annotate your methods as well. So like in your method, if you're passing an argument, you can see that at the rate not null. So it is a programming by contract way to work with. So they have also added this API so that now bean validation could be added to the method signatures as well. Prior to Java E7, you can't inject services, CDI services in your bean validation implementation. Now you can do that. And it also works great with JAX-RS. So now if you look at this REST endpoint, you can see that I am saying that status should be not null here. So in my method, I am saying the status should be not null, and I am using @valid here. So my status object will be validated, and if anything goes wrong, I will get a bad request. So this is something that you have now available in JAX-RS or Java bean validation 1.1. This was earlier not the case. JAX-RS is the standard API that we have. It provides you an API, annotation-based API to write RESTful web services. It's a POJO-based web service, POJO-based programming model where you just annotate your classes with few annotations and you get the JAX-RS RESTful API. It is focused around HTTP centric, so it looks for the HTTP method, and based on that it invokes some method. So if it is a GET request, it will invoke your GET method. If it is a POST method, it will invoke your POST method. So this is a simple JAX-RS resource that we have, if you can see it clearly. So we have a get method and a post method here, and on the get I'm just returning all the goals in my system. On the post I'm creating a new post. So depending upon your request, the method will be invoked. @path is a JAX-RS based annotation. @get to say that this is a get method produces what data type it will produce. So I'm just returning a list of goals, and because my provider already has JSON in it, so it will just transform this list to a JSON object. Similarly, on the response side, on the creation of the goal, I will get a goal request. This will be coming in a JSON format, and I will convert this JSON to my Java object and just create a goal in my database. So all of this is standard JAX-RS that you have. What is new in Java E7? So Java E7 added 3 more things to it. First of all, there was no client API. So if I have to write an API for my web service, earlier there was no way to do that. Now we have a standard REST API to work with it. The second is that now we can use JAX-RS in an asynchronous manner, which means that like if I make a request to my response, it will take a lot of time. So what I can do is that I can just do it in a background. I can do that. I can just suspend the main thread. It will continue working its job, and on the back end I can just process my background thread work. Now I can also add filters to my request. So if I want to do something before getting my request and doing after some post-processing after receiving my request, after delivering my response, I can do these things with filters. So if I look at, let me just show you one of those. If I go to my REST API and I look at, let's say, goal resource, you can see that I am using @logged-in. It is also a filter, so it just checks whether in the session there is a object, there is a username set or not. You just do that. There is also something I have been using here is, let me just look at that in my profile resource. Just show you that in my activity resource. I am so everywhere you can see that I'm using @logged-in annotation, just a filter which intercept my request. If the data, if the user is not certain, it will just give me a 403 unauthorized. That's what it does. I also have filters. What it does is that they just set the user profile into my object, into my return object. So now you can do all these things with Java EE 7, which are required most of the time. So if you have to extend JAX-RS, you probably would be needing filters. Like if you have to gzip your response and all those things, you can use filters for that as well. Interceptors are required if you want to do something with your body of your response. You can do that with interceptors. So why I use just SL4J in my application? SL4J is just an abstraction on top of different logging APIs, so I can plug any of the APIs that I need. So by default, it will just use a simple JDK logging API. If I don't want to use something like log4j or logback, I just use that. So the recommended is that you should use SL4J with logback. Logback is the successor to log4j and has a faster implementation for that. The advantage of using SL4J is that it has a great pattern substitution. So in this log statement, you're just saying logger.debug and just in curly braces. So what happens here is that this string is there is no string concatenation happening here, and you don't have to do logger.isDebug enabled to avoid the string concatenation. Now you don't have to do that because this will be only evaluated if the debug is happening, if your debugger is on. Otherwise, it will not get evaluated. This is a very good API to work with all your logging if you want to use it. And that string should be a logback or log4j depending on what you want to use. We decided to use AngularJS for a few reasons. First of all, we wanted to build a single page application, and on the backend we normally have a REST API, so we just want to use a single page application that will consume our REST API. The advantage that you get with AngularJS is that it's very declarative in nature, and it allows you to extend HTML by new directives. And if something is not already there, you can write your own directive. The simple example being, if we look at this application, the milestone application that we have, and go to one of our goals, let me just show you that. So you will see that this is a calendar heat map which shows you the different dates and the different colors on right now it's green. Otherwise, it could be different colors like a light green or that. So it's a calendar heat map. So there is no directive that I can use to build this graph. So what I did is that I used the library to create my own directive. So AngularJS allows you to write your own directives, and it's a very ideal way to build your single page web application because it has all the routing things enabled in it. So if you have to use AngularJS, it's a very easy thing to get started with. You just have to include AngularJS library, and then you just use AngularJS directive. So here what I'm doing is that I'm just using an ng-init directive and passing an array, and then just iterating over that array and just printing that thing. So it allows me to extend my HTML and do my stuff in that way. So the response would be Karan, Rahul and Shekhar. So I just extended that with my AngularJS directive, ng repeat and ng init. So if you have to build a RESTful API, so what you will normally do is you will have your if I just show you that, source, the map, scripts, so you will have a route provider and you will specify what all routes what they should do. So if we look at the timeline route, so when the timeline route is called, this controller will be called and this controller will fetch the data from my RESTful web service and add that to the scope. Similarly, you can have all those routes in your URL and they will all have their different controllers that will respond to those requests. So if we look at our UI and go here, so you can see that all of these are just simple routes that are happening. So there is no page refresh happening here. So there are just different URLs that are just being mapped to different Angular controllers and they are just responding. And our main page is not refreshing. So that's what you get, advantage that you get out of using AngularJS. So apart from that, we also use something called OpenShift, which few of you have heard about. So the reason we decided to use OpenShift is that it allows us to, it provides us a platform that we can use to build our Java EE applications. So rather than we spinning up our own virtual instances, we just use OpenShift to spin up our instance with Wildfly configured. So to use that, what you need to do is you just have to go to OpenShift.com. So this is a public platform as service. You just go there, log in. Once you're logged in, you can say that I want to create an application. So you can say I want to create an application, just add application. Then you can specify which kind of application you want to create. So right now I'm saying that I have to create a Java application. So in Java application, you can have a JBoss application, JBoss EAP application, Tomcat application. So you can decide whatever application you want to use. I want to use Wildfly application because that's what I want to do. Java E7 application, so I choose that. And I define my name of my application. Let's say the name of the application is test. So this is my test application and I just say create an application. I can also decide whether I want to host my application on the US or in Europe. So I can decide that as well and just create an application. So now on the back end, a full Java EE7 application will be created for you with Wildfly, with cloud enabled and a private Git repository, a Maven project. Full thing will be created for you. You don't have to do anything for it. It will take a few seconds. So what I have done is I have already created an application. So I just refresh and go there. So what it does is that it creates a public URL for your application. So you can just go in here and see that. So it's a public DNS, anybody can access that. Now what you need to do is you just need to clone this application on your local machine. So it creates a private Git repository for you. You just go in here, go to your local machine and just do a Git clone. So this is a private Git repository. You just do a Git clone of this repository. So now our simple Maven project is getting cloned to my local machine. So I already have cloned that. So now if I just go to my IntelliJ IDEA and just open that project. So this is my demo, my student application. I will open a new window and my simple Maven project. It does not have anything extra right now. It just has a simple Java E7 API, Java E7 dependency. That's what it has. And apart from that, it has few HTML and JSP pages. Apart from that, it does not have anything extra. So, but what you get is a full Java E7 application running in cloud. Now what you need to do is just write your code and just git commit and git push and you are done. This is how we create this application. We use OpenShift for that, for our development environment as well. So let's just go ahead. So why OpenShift? So what OpenShift can do for you, it allows you to focus on code, not on configuring your machine. So you don't have to configure a machine, just go to web console, create an application. It is free, so you don't have to pay anything. It speeds up your deployment, so you just do a git commit, git push, it will deploy your application automatically. You don't have to do anything on it, on your part. It can automatically scale your application horizontally. So depending upon the number of requests, it can add multiple instances to it. It is highly efficient in terms that it will idle your application in case it does not receive any HTTP request for 24 hours. So if your application is not receiving a request, it will just idle your gear or your instance. And it allows you to use multiple databases and multiple programming languages. It supports Java, Python, PHP, Ruby, Node, Perl, so you can choose whatever you want to. It also supports MySQL, Mongo and PostgreSQL, so you can, and Redis as well. So you can decide whatever you want to do. So how you do with that, just start by creating a Wildfly app on OpenShift. It will create a Maven project. Just import that Maven project in your Eclipse or IntelliJ IDEA. write your domain model, write your services, and you are done. Just commit it and it will run. So that's how the common deployment or the development environment will work. Now all this is good, but there are a lot of challenges with it. So the first challenge that I faced was that I wanted to use HTML5 rendered from my JAX-RS resources. So currently there is no support for that in terms that you can render your HTML5 pages, but there is no session management that happens. So, and Java EE does not have any provide for OAuth providers like Twitter. So you have to write your own APIs using what you have in your Twitter 4G or Facebook 4G. So you have to write your own. The next challenge is that most of the people think that you have to write your single application as a single page application throughout. I don't think that's the way to write your application. So you have to decide which page makes more sense to write a single page application. Like a dashboard is the one thing that you have to make a single page, but sign in and profile pages are different pages altogether. So you have to decide in that way. So to overcome these challenges, I wrote a framework called Jug, which is JUG. It is a very small framework where what it does, it allows me to render HTML5 pages and do session management for me. So now I can render HTML5 pages and do session management using Jug. It also has few filters of JAX-RS which allows me to use login and session management, that it can help me do that. So it's also open source, anybody can take a look at that and play with it. So this is how a simple way to work with Jug is. So what you do is that you have your JAX-RS endpoint like path. On my home page, I want to render my home.html. So what I'm doing here is that I'm just returning a view. View is something that I have written in Jug. So this will return a home and a template engine. Template engine here is Thymeleaf. Thymeleaf is an HTML5 based Java template engine that I'm using. And I just return my home page here. It will take my HTML5 page, inject a profile, which is a simple user profile, and get it done. So it makes your life much easier. Otherwise, what you have to do is you have to render your HTML manually yourself. So now this is all taken care of by a framework. And I'm just producing a text HTML here. So again, this is how it is you can use it. So if you want to use your own HTML5 template, you just have to write a new template engine API and plug it in. So anybody using Thymeleaf here? Anybody who's using Thymeleaf? So Thymeleaf is a very good API to write HTML5 based pages in your application. It has a very good integration with Spring, but it does not have a good integration with Java EE so far. Spring, they have their own jar that you can include and easily use it, but for Java EE, they don't provide such extension. So the Jug API or Jug framework that I have wrote basically does that for me. There are a few advantages that you get with a Thymeleaf. First of all your documents are valid HTML5 pages, so your designer and developers can work together. There is no problem with that. So you can open the HTML5 page in your browser and it will work fine. With JSF and your JSPs, they can't work. So that's the biggest advantage that you get. They are all valid HTML5 documents. If the document is not valid HTML5, your build will fail or the deployment will fail. So it makes sure that all the pages that you're writing are valid HTML5 pages. And again, it allows you to, it extends HTML5 by tag library. So you just have to add few tags to your HTML data pages and you're good to go. And you can work, designer and developer can work together easily because both are different responsibilities and they can work together much easier. So let me show you one of the page that is Thymeleaf enabled. So if I just open create profile.html, this is a Thymeleaf page. So what you need to do is just have to include a namespace called xml nsph and thymeleaf.org. That's what I did. Apart from that, everything is just standard HTML. Wherever I need to do Thymeleaf specific thing, like I just need to make sure my application are in an absolute form, I just use th.href. Apart from that, all of these things are standard HTML. So like a form here, so normal, you have a normal action here, but when you have Thymeleaf, you have th.action. So it will also open an HTML5 page, which is working fine. In the server-based environment, it will just replace your action with the action that I have provided with the th action. So that's how it helps you. So if you have to use templating engine, HTML5 templating engine, Thymeleaf is a very good option for that. So once we have built this simple application where we didn't have any social features, we were asked to add functionality like ability to follow other users. And view activities on their homepage, the social features that you have in your normal applications. Now things started becoming a bit difficult, and I decided to use Redis now. So Redis is a remote dictionary. So how many people use Redis here? So Redis is a key value store that you can use in your application. It supports persistence as well, so it can write to a disk as well, depending on the configuration that you use. The biggest advantage that you get with Redis is that it has different data types in it, like list, set, sorted set, and hash, and they all have the different use cases. Like set just for storing unique values, and list for storing any ordered list values, sorted for storing time-based value or the score-based values, hashes for storing the data as an object. So these are all different data types that Redis supports. What I decided to use was that I decided to use a simple set. For the functionality here, I'm showing is a create friendship, which means that when a user follows another user, I have to create a friendship between them. So what we do is that we create a set, and we just add a user to the follower. So whoever user is following, I just add to that, and similarly I do the same for the other, just add their following as well. This create a friendship relationship between the two objects. Now what I can do is once I post an activity to my timeline, what I do is that I find all my followers, just iterate over them and update their timeline. So this is how easy it is to work with that. And all the timelines that I have are sorted sets, so they are time enabled. So whatever I will get will always be sorted by time. That's it. Again, the source code is on GitHub, so you can check out. So there are in the core package there are repositories. So if I just go back here in my repository, Redis space, so I have a timeline repository. So here I am doing all those stuff where I'm just maintaining my different timelines. So Redis is very suitable when you have to build this kind of a functionality, following and functionalities like updating timelines and all those things. So this is a fan out approach where I'm updating all the user timelines. Again, for storing the timeline, I just get the data and write to my sorted set. That's what I do. Nothing special here. There are other common use cases or other use cases where I have used Redis. The first is maintaining counters. So if you have to make sure that your counters are updated, like number of users in your application, Redis is a very good use case for that. It is single-threaded and atomic, so it maintains the counter well. Like showing latest activities on user homepage, again, good use case for Redis, and caching. So these are the three other areas where I'm using Redis in my application. Once we have built this functionality, I was asked to build a location-aware job search engine or location-aware user search. So if we go back to our application, look at the application, this is my run. And if I go to my friends, all of these I talked about the suggestions that I am getting on the right are based on the location. So based on the location means taking the data from my profile, which is from India. So all the users that are on the right are from India. And if they're near to my location, they will get that. For that, what I'm doing is I'm using MongoDB. So MongoDB is a NoSQL database, which is document store database. What it does is store data in the form of documents. It has a very good support for geospatial indexing. So what you need to do is you just need to create data in the form of JSON. You say that this is my JSON document of type point, just like a point, and this is my coordinate. This is the latitude and longitude of my location. So what I have done is I have a username and his coordinates. So every user has a coordinate. And when you have to query the data, you just do a near query. So find me all the users who are near to this location. So it gives me return me all the users that are near to my location, and I can just render on my page. So what I do here is this is a simple API. So again, what I'm using here is MongoDB Java driver. It's the standard driver that MongoDB provides, and I just create a query, a near query. If you look at on the bottom method, it's a near query that I'm creating. Find me all the users who are near to my current location, and just execute that. It returns me all the results, and I just convert them into a string and return back. Again, this is all in the API. So if you look at Mongo, there is a user profile API which does all that part. So you can find that there's a suggester which does all those things, location-based suggester. So this is where the source code sits. You can find all that. Okay. So MongoDB is used for geospatial indexing and for finding location-based searches. Once we are done with that, the next thing that we need to do is build beautiful graphs. So I'm not a designer, so I don't know how to build beautiful graphs, but I need to do that. One way to do that is, these days everybody uses d3.js. How many people have used d3.js? How many will like using it? So there is an API called c3.js, which is built on d3.js, which takes care of all the nitty-gritties of d3.js and provide a very simple API to write graphs. I'm using c3.js in my application. I think I'm the only one who's using that API. I've never seen anybody else using c3.js, but it's a very good API that you guys can use. It's based on top of d3.js, so it takes care of all the API nitty-gritties, and it's open source as well. You can find it on c3.js.org. This is how you write a simple donut chart here. So this is a very simple API. You just do c3.generate, provide the type of chart you want to create, provide the div ID where you want to create, and provide the data. That's what it needs. It does not need any other thing. Otherwise, you have to do dd3.select and do all those things. Now you don't need to do anything. So it's a very good API if you have to work with C3. All the charts that we are seeing in this example application are C3 created. So if you have to see how C3 works, you can just look at the code and find it. So all these graphs are from C3. Apart from this calendar heat map, this is something different. Apart from that, everything is D3 enabled. And last thing that I will talk about is if you have to configure error pages in your Java EE application, like for errors like 500, 404, now there's a standard way to do that in your web.inf. You can specify for error code what you want to do, and it will take care of the rest. So you can take care of this very well now. So Java EE 7 now provides you all these capabilities that you can use to build applications. The biggest things that are missing from Java EE is NoSQL support. They don't have anything for that. People have extended JPA to use NoSQL, but I think that's a very wrong way to do it. JPA was never meant to build NoSQL applications, but people have done that. Other thing is MVC framework is totally missing from Java EE. In Java EE 8 that is coming. Probably NoSQL is also coming. Datetime API we have in Java 8, but that is not integrated to the API yet. We need that badly. And again, that would be the Java EE 8. So there are a lot of things that I have used in this application which showcase the limitations of Java EE here, but these all things are coming. So I have in touch with Java EE guys here and they are trying to work on that. So Java EE 8 will be having all these things fixed. So that's it from me. Any questions? Yeah, go ahead.
According to OpenShift,
Yeah. You could have that. So what you could do is that you can configure your application to say that I want to use this branch for deployment. So you RSC configure app is I think is the command. By default it pushes master to that, but you can say that I want to use master for development but prod for production. So you can do that. RSC is a command line client for OpenShift if you use.
you would have different namespaces.
Yeah, you could have different namespaces. So you could have that. Any other question? Yeah, go ahead.
Why would you use Redis for followers and following stuff for the caching? Sure, but for the actual storage of the relationships?
So the other way could be using something like a Neo4j for that. If I had to use that, another NoSQL database. The reason I decided to use that was that it was a simplistic solution for me to maintain the relationships. Like a user could have a set where I will maintain all its followers and another set for maintaining all its following. So that was a simplistic way to me for building that relation. Otherwise, I would have to use a relation database and I have to map mapping between all those things. How would you do that in a relation database? You have to have all those relationships built into a relation database. Then when you have to query that, there will be all joins that you have to make. So I just wanted to avoid all those things. That's why I use that. You could take that in a relation database as well. Yeah. But the reason was that. Any other question? Again, the same thing you could do with a MongoDB as well. So you could do that as well. Any other questions? No? Then we're done. Thanks a lot.